Good afternoon, ladies and gentlemen, here in New York City at 12th Cloud Expo, New York. Our next general session, good morning, good afternoon, good evening, if you're watching this out there on the World Wide Web and following it that way. Our next session is a two-hander, although I only have the first of the two speakers with me. First, we have Kedar Poduri from Citrix, who in turn, at some point, unknown to me, will be introducing Jonathan Cohen from oh, I can't even say it. You say it. Alcatel-Lucent. Oh, it's not going to help me. So, give it up, please, for Kedar, if you haven't seen him before. Great speaker. And in turn, when Jonathan comes, I insist on thunderous applause. Take it away.
Thank you. Welcome, everyone. First, apologies if you were in my earlier session today. Some of the content could overlap. In spite of a couple of sessions here, I'm still getting used to this layout. So bear with me on that. Today, we're going to present a joint cloud solution that Citrix and Alcatel has put together. It's actually called CloudBand, an offering from Alcatel. And I have with me Jonathan Cohen from the Media and Communications division at Alcatel. And I'm Kedar Poduri, I'm part of the cloud platforms at Citrix. So I'm going to start off with the orchestration layer. That's an integral part of the CloudBand. And then Jonathan would cover the CloudBand solution as a whole after that. So with that, we can get started. So before I go into the details of the orchestration, let me spend a couple of minutes on our vision at Citrix and how we try to bring our solutions together for cloud services. So the key aspect that when we talk to our customers, et cetera, is it's inevitable that the trends like cloud and mobility have changed the behavior of users. You know, all of us have multiple devices that we work with on a daily basis, be it smartphones and tablets and laptops. We download our apps, we carry them home, we get them to work, and we customize that to suit our needs. And when we come to work, we expect IT to be able to work with them as well. And thanks to all the offerings like app stores from Apple or Android, people are used to having these services in a certain way, be it self-service or on-demand, always available, customized to my needs. And very soon, the expectation of IT services as well is that they will follow the same norm. And traditionally, IT has been in a different paradigm, and to be able to move to a place where you can offer IT as a service is a long journey for many enterprises. And obviously, many have started on that journey. Many enterprises are now fully virtualized or well on their way to there. And many of them have begun building the private clouds, which we believe are essential steps to be able to get to the true IT as a service. And we at Citrix would like to get our products into a solution that can enable key aspects of IT as a service. And obviously, we work with our partners as well, because many of these are data center-wide solutions. And having a good partner ecosystem to get to IT as a service is key. So with that as the background, I'll spend a few minutes on the orchestration layer, which basically does all the data center management in a private cloud or a public cloud, and also a key component to the CloudBand solution, and take you through some of the core aspects of this platform that play into solutions that Alcatel is bringing together with the CloudBand. So Cloud Platform is a Citrix certified version of the Cloud Stack, which is an open source project. So it's part of the Apache Software Foundation. Much like Hadoop, it's a community-driven project. And a lot of developers other than Citrix are part of that community and actively drive that project. In fact, the last statistics show that it's one of the most active Apache project out there. So what Citrix does is takes that and certifies and qualifies and supports a version of it. So when we talk about Cloud Platform, it's a turnkey infrastructure as a service orchestration layer software. And when we say turnkey, it is actually a turnkey. We have had customers who downloaded the software and pretty much on their own have gone from scratch to a POC cloud in less than a few hours. And routinely, our customers, once their design is complete, get to production clouds in a matter of few weeks. And the reason why customers are able to do that is because we, over time, have seen all the aspects that go into building a private cloud and have brought all those pieces together into one platform. So all these various modules are well integrated, and whenever we think about adding functionality in one aspect of the platform, we try to make sure that it actually flows through all the other aspects of the platform as well. So over time, the platform has built in a lot of functionality. But if you look at what are some of the key things there, the first is the fact that it's secure and multi-tenant. The platform initially was catered to the service provider market, which were early on, obviously with AWS offering services. Service provider customers wanted to have either an offering that can compete with Amazon or that can differentiate from Amazon. But either way, they leveraged the platform to build those public clouds as opposed to coming up with their own orchestration layer. So all the aspects that go into building a public cloud are built into the platform. Massively scalable. Again, one of the key things as we talk about carrier-grade clouds and applications, and I'll talk a little bit more about it. We have customers who build clouds in excess of 40,000 hosts and growing quickly. So scale is sort of a solved equation in the cloud platform. And beyond that, we try to work with a variety of vendors and variety of technologies, whether it be a hypervisor layer or load balancers or firewalls. You think of a technology that you would need to work in the data center, we make sure that we work with many of them. So as and when you deploy an orchestration layer to automate those, we have tight integrations that you can leverage out of the box. So going back to how do we deliver this turnkey software, that's because when we think of building a private cloud, obviously everybody starts off with storage, compute, and network aspects of it. And if you look at platforms out there, they do a fairly good job on the compute and the storage. And cloud platform, especially on the network side, does a much better job in terms of the variety of options that it provides end users or admins to leverage and suit their applications and their needs in the data center. But beyond that, the other aspects that go into building the private cloud in terms of putting out load balancers and firewalls and VPNs out there, right? Once you build a private cloud, how do you give access to your users securely to the cloud? So being able to have those ability to orchestrate VPNs, et cetera, is a key part of the building a self-service private cloud. Same goes with respect to firewalls and load balancers to provide that secure layer, security layer in front of the private cloud. And while these are sort of not so critical eventually, but the fact that they have to be integrated as part of the orchestration layer plays a big role for the whole self-service promise that admin has to the end users. So being able to provide a single sign-on experience for all the solutions that IT delivers, or having an image management layer that can take care of the VM sprawl that are often seen in the virtualization layers. So all these problems that were part of the virtualization layer have to be solved in the cloud as that is one of the promises. So when you move to a cloud, you don't want the problems to exacerbate, but essentially the platform has to take care of all these things automatically. And on the APIs front, we have developers that have written to Amazon, and when you build public clouds or private clouds, they want the same tools to work with it. Or you simply want to write natively to the platform to enrich or to take care of all the features that the platform provides and automate that. So having a rich API layer is also a key part of the platform. And then metering, of course, right? So you want to have a clear visibility of where each CPU cycle is going, who is using that storage byte, or how much of a business unit is consuming that network bits. So you want to be able to have clear idea of every resource in the cloud and who is accessing what. So as I dive into the orchestration layer, it's pretty complex. It does a lot of things. But I want to focus only on 3 things as it relates to especially the ALU CloudBand solution and the carrier-grade clouds. The first of which is the application management. And in the end, obviously, you're building clouds to deliver applications. So it's always ideal for the admin to start off with what applications he wants to deliver and then build the infrastructure underneath to suit that. The second is to make sure that the cloud has a scalable architecture. So essentially, not just scaling in terms of size, but also scaling in terms of components that can be differentiated. So for example, if you have a storage layer that you want to scale, that has to be scaled independent of compute and network. Right? So depending on your application needs, maybe you want to be able to scale up the network and don't care about compute and storage as much. So being able to independently scale each of those infrastructure components within the data center, again, becomes critical to the cost component that you want to control at the end. And then open standards, being able to work with variety of vendors, using variety of protocols is also key to building that solution. So on the application side, to be honest, 3 years ago, we didn't care about applications. We said we want to build infrastructure as a service layer. All we care about is VMs, and we are completely agnostic to applications. And the platform evolved to architectures that customers wanted. And for most parts, customers built a hybrid architecture that they thought would solve both what we call the traditional applications and the cloud applications, because they wanted to have one architecture. The reality was that that architecture was neither good for the traditional applications nor for the cloud applications. The reason is that the requirements and the applications, the nature of these applications is vastly different. So if you look at the traditional applications, the assumption behind those applications when the developers wrote those was that there is an infrastructure layer underneath that's always up and running. And as a result, if the app server goes down or the database goes down, it's OK for the app to go down. And that, in turn, made the IT admins behave in a particular fashion. Right? They wanted to make sure that the infrastructure that they have is always up and running. And apart from making sure that they have a ton of people overlooking a few servers, they also made sure that there is redundancy at all layers, whether it be in the core routing layer or in the storage controllers in terms of SANs or hosts with multiple legs and so on and so forth. So the redundancy was one way to brace against failure. And also making sure that they typically buy top-of-the-line servers or storage to ensure, again, against platforms. Whereas the cloud applications have a different expectation. Right? They expect that the underlying infrastructure will fail, and hence either the cloud architecture provides some kind of reliability for the application, or sometimes the application itself has built reliability into its architecture. And hence, it doesn't care about having redundancy at the infrastructure layers. So, but the key requirement from either applications is that it has to run reliably. And the degree of reliability based on it's a tier 1 application or a tier 2 application might vary, but that variation is there both in traditional and in cloud applications. And when we looked at the different requirements and when we looked at how one could build reliably an architecture that suits those applications, what we found was that the underlying architecture often almost is diametrically different. So, for example, if you look at under the hoods of a traditional data center, it's typically set up with a hypervisor-rich, a functionality-rich hypervisor, like a vCenter or a Hyper-V. And they provide functions like DRS and storage migration and HA. And when it comes to networking, oftentimes it's virtual LANs that are required for compliance, et cetera. And typically they go to top of the rack, top of the line servers for scale up. Basically, you want to have as much memory and computing power in a server as possible. And you need to have a SAN storage out there to be able to provide that reliable storage layer to the applications. And in contrast, if you look at a architecture, okay, if you look at underneath the hood for an Amazon or an eBay or Google, it's built quite differently. And here, you don't see complex networking. You'll see a layer 3 network, oftentimes with SDNs to provide the vast scalability that people are looking for. And also, this servers are typically commodity. Hypervisor is barely there to provide virtualization. It doesn't provide any of the advanced functions that you would expect in a typical hypervisor. So it's, again, built quite differently from the traditional application. So the goal is that depending on the cloud you're building and the applications you want to deliver, the underlying architecture is quite different. So it's almost always required, if you want to deliver certain SLAs on the private cloud or public cloud, that you start with the application, determine the architecture that you would want to have, and make sure that the platform you're building supports that architecture. The second aspect of the application is the application management as a whole. You want to make sure that the platform understands the concept of an application, that it has multiple tiers and maybe a small number of VMs, and certain rules exist between these VMs and between these tiers in terms of firewalls, et cetera. Maybe you want to spin up some load balancers to scale this application up and down. You want the orchestration layer to make sure that it understands the components of application. If you say, for example, hey, stop my application or migrate my application, it has the underlying ability to do that as an entire entity, as opposed to, I need to now move 10 VMs, and I'm not sure whether my application is migrated or not. So that's a key aspect of application management as well. So the second aspect of the cloud is the flexible architecture. So on the left, you see is an example of a private or a public cloud was built cloud with multiple regions. So if you are familiar with Amazon, these are like the Amazon regions. And within the region, you have an individual failure units called the availability zones. So from a scalability perspective, for example, each of the regions is an independent cloud. So the 40,000, et cetera, that I talked about, you can actually build clouds with hundreds of thousands of hosts as long as you can split them up into regions. And because each region, it acts independently, except for the account management, et cetera, it does any failure in one region or even one availability zone does not impact any other regions. And if you want to deploy applications that can run 24/7, you want to offer 4 nines or 5 nines reliability, being able to have this modular architecture that's spread across geographical regions is, again, critical. And I don't want to go into the details of the underlying architecture, but it's just not at the region level, but every single component, right from compute to storage to network, it's built in such a way that any of those individual components can be scaled, and the application can be deployed even within a data center reliably. Right? For example, if you want to deploy an application with web VMs, you can say with a simple configuration, the platform to deploy those web VMs as far as possible in the data center. So a host can fail, but the application is running. A shared storage can fail, but the application is running. And for that matter, an entire data center can fail, and the application is continuous to run. And that is how you build the high reliable applications in the cloud. And lastly, when we talk about open platform and open standards, a key aspect of orchestration layer that we try to embrace is that we do not want to change the behavior of the admin. For example, the admin or the operators within the data center may have access to certain hypervisors, may have access to certain load balancers and firewalls, and they've built expertise on top of that. Just because they're trying to build a cloud does not mean that now they have to work with a different set of vendors. That, to us, is not reasonable. So what we try to do is offer services that obviously come out of the box through some of the software devices that we provide, but also make sure that we integrate well with every other vendor that you probably would see in a data center out there. And on the compute side, for example, like I said, we work with a variety of hypervisors. And some customers don't care about hypervisor. We say we want a bare metal cloud, and they want bare metal as a service. We can do that. And also from a platform perspective, storage and networking, offering different kinds of storage offered by different vendors, or same on the networking, is key to being able to build the data center in the fashion that you want with the vendors that you want. And that's also a key aspect of the platform in terms of how flexible it is. And lastly, taking that to the next level, a platform is a platform because it has a lot of partners in the ecosystem and have built a variety of solutions. Although we focus on ALU today on a specific solution that they have built, in general, the platform is built in such a way that it has well-defined API interfaces that other partners can integrate to and offer their differentiated solutions on top of the platform, which in fact, and Jonathan will talk about this, Alcatel also has leveraged. And when the solution comes together, it's all integrated and comes off as one solution to the admin, not as 5 different things that he has to put together. So with that, I'll turn it over to Jonathan to cover the rest.
Which button do I push to advance? Okay. Thank you very much, Kedar. Firstly, my name is Jonathan Cohen. I'm from Alcatel-Lucent. As Kedar mentioned, we have built a cloud management system that rides on top of cloud stack, and want to talk to you about why we built it, what are we using it for, and hopefully what you'll take away from the presentation is getting some appreciation for what might be different about the kinds of requirements that the carriers were looking for, and we think that they'll need to deal with the scale and complexity of typical applications that run in their network versus what you might be dealing with for typical enterprise applications. Probably the first point I'd want to make is carriers build services. Services need to be looked at in terms of an end-to-end viewpoint. They typically have SLAs on them. Some of these SLAs might require that you are running 5 nines of reliability, which literally means 4 minutes of downtime permissible in the course of a calendar year. So the promise of the technologies, the promise of the cloud, the promise of the virtualization, and all of the automation that comes along with it, they want it for several reasons. There's a fundamental belief driven by some activities that are going on in the telecommunications market, namely an initiative called NFV, or the Network Function Virtualization, is to leverage what we know to be true about the benefits of virtualization and the abstraction of software from the tight coupling with hardware, and being able to launch workloads pretty much anywhere an appropriate set of resources is available to reduce cost, improve, for all of the reasons that we love cloud, improve asset optimization, and reduce operating costs through automation. So when we talk about the promise of cloud, when we talk about NFV as a model, and we apply the technologies that are prevalent, we need agility. And by agility, this typically means being able to bring services out to market faster than they currently are. Most estimates for a service provider to bring out a brand new service to market might take as long as 18 months. From the time the concept is initiated, through all of the trials, through all of the systems work that needs to be done, you could be looking at minimum 12, maybe as much as 24 months to bring a service to market. So the agility to be able to do things faster is very, very important. We're dealing with a lot of complex software. For those of you who write applications, you might look at some of the code that exists and the hacks that have to be performed to get it to work, and you'd come to the conclusion that it's your worst nightmare. They are complicated systems, and they are tightly coupled with the underlying hardware. That causes all kinds of fits and starts around maintenance. So the need to reduce complexity drives simplicity. Elasticity is a problem. Elasticity, the capacity planning by most carriers is a challenge. And the ability to look at a pool of resources that might come from a set of cloud compute and storage resources, as opposed to having to build a capacity plan for a given network element, is very appealing. And obviously, cost savings to be brought out by asset optimization and commonality in sparing, commonality in tooling, commonality in processes, being able to get to a much simpler way of deploying and of course, without impacting the services. So having maintenance windows that can be done to bring up new versions of software without causing a service outage. In order to do these things, it's going to require significant transformation in the carrier markets. They have adopted a lot of the virtualization technologies to run the typical IT systems that most any other enterprise works on. But when you start to look at taking these same concepts and applying them to the core applications that run inside the network, major undertaking to transform the processes, a lot of organizational disruption, but they see the benefit. The payback when you're spending billions of dollars per year to operate a network, when you can take advantage of virtualization and cloud technologies, the payback can be massive. We'll talk about the shared infrastructure. It's the same concepts that you're all dealing with in the cloud today. The reliability models I mentioned, and I really think that this is an important takeaway. For those of you who have to look at high availability systems, 5 nines is a major undertaking. And the way that's done today for most of the elements that are inside the core network is, as I said, you've built tightly coupled systems. And you've specifically knitted together all of the mechanisms that ensure that if there's a component failure, that it doesn't take down the system. A lot of these systems, we're talking about shared state information that has to flow, for those of you familiar with firewalls. That concept, but at a grand scale, not trivial undertakings. To move that to the cloud requires a lot of re-architecting and rewriting of that middleware layer. So there were some key platform requirements that had to be addressed as we looked at building the solution. And as I mentioned, it is a different model with a lot of different tooling, and most importantly, the operators themselves had to get into the mindset of actually tackling the opportunity here. Scale is huge. You know, I would say even the smallest carriers are probably as large, if not larger, than most enterprises, most of the largest enterprises that you see. Granted, there are going to be large banks and other financial institutions that probably have as much compute resources as a carrier, but they're far and few between. The largest of the carriers, and we talk in the United States where some carriers have hundreds of millions of subscribers. When you go to Europe or Asia, the numbers go to 300-400 million subscribers per carrier. You start thinking about the scale associated with managing the data within the applications, it's just a huge undertaking. Tens of thousands of virtual machines, not only in a single data center, but in a distributed data center. The lifecycle management is the key area. When we talk about what we build from a cloud management system, it was the focus on the application lifecycle management, how you get that automation specifically tuned to the requirements of the carrier. Leveraging the network, possibly the most difficult thing about moving workloads, standing them up, shutting them down, introducing new equipment into your asset pool is managing the networking. And we'll talk a little bit about the difficulty associated with doing that. And as mentioned, as Kedar mentioned, open multi-vendor. We don't and didn't expect when we created this cloud management system that all of the network applications that would run in the carrier network would come from Alcatel-Lucent. So you have to go into this with an appreciation that you've built a platform that needs to be usable by your competitors. And that's just the way of life in the telecom equipment manufacturing market. Automation is key. You cannot understate the need for automation in the carriers. When you look at all of the number of people that they employ doing network operations and management, the numbers are just huge. So you strive to get it to plug and play, and you want to automate that cloud. We talk about automating 3 hours from bare metal to fully functional. That literally means that you're taking a rack and stack approach, not dissimilar to what Amazon does, but literally taking a rack that can have however many virtual machines it is capable of, and that number obviously will change over time as Intel and AMD change the processors and the specifications. The benefit here is that you're adding and removing assets from that pool, and once they're added, they get federated. Automation of the cloud for us meant that we did all the integration necessary to take CloudStack and KVM and whatever other elements and build it in such a way that from an image it could be plugged into the network and be made available to the provisioning systems within 3 hours. Applications then need to be layered on top of that separately, but the times to spin them up much, much shorter. But it all requires heavy-duty automation. When you orchestrate, I mentioned the number of virtual machines, but we're talking tens of thousands of virtual machines spread over hundreds, potentially, I should say dozens of data centers, 10, 20, 40 data centers sometimes. That's not the only place compute resources or storage resources exist. They also exist in central offices, non-data center environments. So the ability of an orchestration system to manage your assets is far-flung. Depending upon the operator, some are going to be far worse than others, but we could be talking about putting compute resources in the basement of a building in an air-conditioned space. And that type of information then needs to be updated to the cloud management system so that it knows about the existence, and it can then place loads onto those assets to a given script. We call it a recipe. For those of you who have been dealing with automation, probably not a new term, but specifically for our purposes, it was not only the recipe for the automation of the life cycle of that application, it also had to apply the business rules, the when to spin it up, when to spin it down, what to do in the event of a failure, elasticity rules, those types of things. Very, very complicated topic, and we spent a lot of our Bell Labs folks' time actually figuring out these placement algorithms on how to make sure that we got the loads to the right places and how to deal with things when the availability of that load was not there. Leveraging the network, I mentioned the complexities of building clouds as it relates to the network. Most everyone is familiar with a VLAN. And the challenge with VLAN grows as the number of devices on those VLANs grow. It's not a very effective way to build a scaled network. So what you have to do is find ways, and what we've done is we actually created a new business unit called Nuage, who has dealt with the complexities of software-defined networking and has created the capabilities which are managed from the cloud management system to take policies that describe what network a given virtual machine is supposed to belong to and automate adding that virtual machine when it gets spun up into the proper VM, that VM into the proper network configuration, inheriting all of the security and performance attributes that are supposed to come along with it. Orchestration in the distributed data centers, I know that Kedar was primarily talking about private clouds. But one of the things that we understood from the jump about our customers were they were probably going to build a hybrid where they would build out their own private data center capacity as necessary, but would want, for the purposes of disaster recovery or to augment capacity, the ability to federate their needs with public clouds. So basically from day one, the CloudBand management system was intended to support that hybrid model where you would federate your private cloud resources with public cloud resources, and specifically that means the likes of Rackspace and Amazon. Managing the life cycle is key to the real focus of Alcatel-Lucent in the CloudBand management space. We have created what we call a carrier pass layer. Now, I believe we've discussed the pass model as what comes after virtualization. We're talking about beyond virtualization. We've got virtualized applications, but they need to be in the carrier context, onboarded such that they can be used, such that they can be consumed by the carriers properly. And this carrier pass layer is really addressing what goes on down in the application lifecycle. You start with onboarding it when you write these recipes and scripts to be able to automate standing up the applications. But you've got to deploy the applications, you've got to monitor. Heavy dose of OSS, BSS integration that goes on here. And the correlation of the performance of the network with the performance of the virtual machines, with the performance of the applications, which can looking at things like the number of active subscribers, the number of transactions per second, the number of sessions that are opened in a given moment. Scaling up, scaling down, when to launch additional virtual machines, where to place those virtual machines. Healing, I mentioned earlier, what happens in the event that you lose a component? How do you react to that scenario? All of these things become automated and form the basis of, for the carriers, probably the main difference between what you would see in the enterprise space versus what CloudBand management system is intended to do, which is to deal with the life cycle of these carrier applications at the massive scale that they exist. And why do I keep doing this? Okay, there we go. Be open and multi-vendor. You know, clearly we partnered with Citrix and CloudStack to build the CloudBand nodes. You'll see the next slide talks about the interfaces that we have northbound and southbound via APIs, cloud drivers, network drivers. We work very closely with Citrix around the portal. But the world dictates that you can't pick only one partner to work with. So we understand we need to support KVM, we need to support VMware, we need to support Xen, OpenStack, CloudStack, etc. That is the nature of the world that we live in and is probably what you're also seeing on a regular basis. But the way you do it smartly is through open APIs. We've done a lot of extending of the open standards where active participants with Citrix, with the OpenStack groups, and this is the way that our carrier customers are telling us they want to be able to consume the network function virtualization model, which is largely going to be built on, in addition to the virtualization of the applications, the consumption of a lot of industry standard types of technologies. So as I mentioned earlier, if you look at the interaction between Alcatel-Lucent and Citrix around the CloudBand, We have built the distributed cloud nodes that I showed you before based upon Cloud Stack, and created specifically something called a node driver that handles all of those APIs and the automation between the compute and storage assets and the CloudBand management system. The network drivers also working with a lot of the standards in the SDN space. And on the northbound interfaces into the Citrix portal, as well as intend to consume other Citrix assets such as VDI and other of their desktop products. But CloudBand basically is an integration platform to not only onboard the applications, to create that virtualization function and to automate the onboarding of the applications, but to manage the full infrastructure that's necessary for a carrier to be able to use the cloud technologies to move to this new deployment model, which we'll find very, very challenging for sure, but worthwhile. And that is a goal that I believe, regardless of the market that we serve, we all aspire to. We understand that the cloud has great potential, and now it's just a matter of getting it moving along. And I guess, Kedar, we can have you come back up and we can field questions.
You're going to take them from the stage? Here comes the first one. Thank you for the lights.
Ed, the fellow from Alcatel-Lucent, question for him. He had mentioned that from the time you start until you deploy a system, roughly 18 months. And correct me, I don't want to put words in your, improperly say something, but what I wanted to ask was, with regard to that comment, what kind of systems are we deploying in that 18-month period of time? Is it a data warehouse?
Not referring to a system.
Are we talking OLTP? Could you elaborate on that?
No. When you talk about data warehouses and OLTPs, you're talking about components. I would say that a messaging system would be a component. When we talk 18 to 24 months, we're talking about the service development cycles. So for instance, I'll give you the example of VoLTE, Voice over LTE. To be able to build that type of a service, the mobile operators probably from the time they write their service description till they actually launch it and having gone through all of their service development process may have spent 24 months. But I was referring specifically to a working service that a bill gets rendered against, not a building block of a system.
Okie dokie. There's time for one more question. We've got another session coming up, and the show floor is still open, so it's your last chance to get there today. Here you are.
You mentioned about 5 nines availability for this carrier space. So do you have any use cases in the US, any carriers using this kind of?
Using NFV and the cloud, they're all going down the path of commercial trials. The guiding body for this is ETSI, ETSI. The effort was kicked off about 6 months ago. Almost all of at least the US-based carriers are in discussions with multiple vendors, not just with Alcatel-Lucent, but multiple of their vendors about virtualizing their current network applications, most of which are delivered on ATCA, where they're tightly coupled with the hardware. And what you have to deal with not only the availability of a cloud infrastructure to run the VMs on, but you also need to have to worry about the availability of the application software to be virtualized and available to run in that environment. But it's still early days. We're talking probably realistically no commercial deployments until sometime in 2014. But trials are starting now.
Okay. So we'll have the IMS core and the NFV kind of
correct. IMS is available today,
right,
typically in the ATCA formats. and going to virtualize. In fact, that is one of the lead use cases for the NFV right now is virtualized IMS.
Thank you.
You're welcome.
Thank you for your questions. I'm going to have to wind you up because I bet they could go on. Let us thank Jonathan and Kedar for their highly informative presentation.